to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of m minus 2 to the power of n equals 2016. So what I'm first going to do is I'm going to set m equal to n plus k. K being a constant. Now, if this is true, then we also know that n is equal to m minus k. And k is a constant. So now what I'm going to do is I'm going to replace m with n plus k. So I'm going to rewrite this as 2 to the power of n plus k minus 2 to the power of n equals 2016. Now, if we have something in the form a to the power of n plus m, this can also be written as a to the power of n times a to the power of m. So 2 to the power of n plus k, this can be written as 2 to the power of n times 2 to the power of k. And we are still subtracting this with 2 to the power of n, and this is equal to 2016. So now what I'm going to do is I'm actually going to rewrite 2016 as 2 to the power of 5 times 63. And this is still equal to, what I'm going to do is I'm going to factor out 2 to the power of n from this. So if I factor out 2 to the power of n, I get 2 to the power of n times 2 to the power of k divided by 2 to the power of n is simply 2 to the power of k, and 2 to the power of n divided by 2 to the power of n is 1, so minus 1. So we get 2 to the power of n times 2 to the power of k minus 1, and this is still equal to 2 to the power of 5 times 63. Now, as you can see, this is even. So I'm writing E for even. This is going to be odd. I'm going to write an O for odd, and this is odd because we're going to subtract 1 from the 2 to the power of k. This is 2 to the power of n, so any number that you plug in, this would be even because it's 2 to the power of something, and 2 is an even number. However, we're still going to subtract 1, so this is actually going to be odd. And now from this, remember, this is even. 2 to the power of anything will result in an even number, and 63 is odd. So I'm writing O for odd. Now what I'm going to do is I'm going to set the evens equal to each other. So 2 to the power of n equals 2 to the power of 5. And because these two have the same bases, we know that the exponents are equal to each other, meaning n is equal to 5. And now what we're going to do is we're going to set the odds equal to each other. So 2 to the power of k minus 1 is equal to 63. So now if I add 1 on both sides, I get 2 to the power of k equals 63 plus 1 is 64. And what 2 to the power of what equals 64? 6. So k is equal to 6. So we know that m is equal to n plus k. So we already have the values for n and k. N is 5 and k is 6. Meaning m is equal to 5 plus 6, which is 11. So m is 11. So now we have our values for n and m. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x squared minus 6 squared minus 6 is equal to x. And what I'm first going to do is I'm actually going to set a equal to x squared minus 6. So I'm going to set the variable a equal to x squared minus 6. And if this is true, and if we substitute in a for x squared minus 6, our equation would be a squared minus 6 is equal to x. So now if this is true, and let's say this is equation 1 and this is equation 2. Now, I'm actually going to subtract both of these. I'm going to subtract x squared minus a squared. So x squared minus a squared. And what ends up happening is we get the result as a minus x. X squared minus a squared is equal to a minus x. So if we have something in the form m squared minus n squared, this can also be written as m plus n times m minus n. Meaning x squared minus a squared is equal to x plus a times x minus a. And now if I add x on both sides, we would get plus x. And then if I subtract a on both sides, we would get minus a. And now because there's nothing left on our right-hand side, we would simply have 0. So now I'm going to factor out x minus a from this. So x minus a times x minus a, x plus a times x minus a divided by x minus a is simply just x plus a. And x minus a divided by x minus a is 1. So we have x plus a plus 1. And this is equal to 0. So now this would actually give us two equations. We would have x minus a is equal to 0. And for this, if we add a on both sides, we simply get x is equal to a. And if x is equal to x squared minus 6, because remember, a is equal to x squared minus 6 and x equals a. That means x equals x squared minus 6. And if we subtract by x on both sides, so we get 0 is equal to x squared minus x minus 6. Now we have a quadratic equation, and this would actually be simplified to 0 is equal to x minus 3 times x plus 2, meaning our two solutions for x would be x is equal to 3 and x is equal to negative 2. However, there is still another equation. We still have x plus a plus 1 equals 0. So if x plus a plus 1 is equal to 0, that means that x is equal to, I'm going to subtract everything and move it to the right hand side, negative a minus 1. And I'm actually going to plug in a. A is x squared minus 6, so this means x is equal to negative 1 times x squared minus 6 is negative x squared plus 6 minus 1, and 6 minus 1 is 5. So we have negative x squared plus 5. So now if we subtract x on both sides, we get 0 is equal to x squared plus x minus 5. And if we plug this into our quadratic formula, we get negative 1 plus or minus the square root of 21 over 2. So these are our two other equations. We have negative 1 plus the square root of 21 over 2 and negative 1 minus the square root of 21 over 2.